Hi everyone, how are you?
Hey, Professor.
Hi Chris, I hope you're doing okay. It is week 7, yay! We're halfway there practically. Yeah, Monday is always so crazy busy, but you know, it's good. Busy is good, I guess. I'm glad you're doing good. At least it's cooling down now, right? The weather is kind of a little nicer than last week. So. Fall is coming, Halloween is coming. So they have a UCR event. Let me see if I can attach the file to chat here. I didn't have a chance to make an announcement for you guys yet, but if you're interested in transferring, they have upcoming events. So STEM, they just sent me some information. So the file that I dropped into the chat is the engineering, Bourne's College of Engineering at UCR. They have an event tomorrow at 1 to 2 or 5 to 6. So if you want to attend, you can click on the registration link on the flyer. So that way you can ask questions if you're looking to transfer for engineering program. Oh, that's great. I'm so happy. Yeah, so if you recall, some of the students submitted the scholarship information. So I had forwarded, and then I guess if some of you, I really pushed for many students to get it. I mean, it's a little bit of money that can help you. But anyway, I'm happy that some of you got some result back, or at least hear back from them. And I think it's with Sempra Energy this year. They told me it was GE and it was confusing. But anyway, all right. So let's crack in on Python, right? So
Do
I
you
just
have
want to yes.
do you have an update on the test for Security Plus?
So I had reached out to Certiport once again to ask the rep to give me the quote because it's now October. Like he said, he would give me the quote by October. So I looked at the list that they gave me for Certiport. It's not going to be CompTIA. I just want to let you know it's going to be Security Essential through Microsoft, which is a very similar exam. So that will be what we could purchase because CompTIA won't sell us the individual voucher. Or actually they will sell us the individual voucher, but they won't sell us the institution license for the voucher. So we couldn't get the funding to distribute for the individual voucher. They originally did a couple years back, but they stopped doing that because I guess some colleges, they abuse it. So I'm unable to get that from CompTIA. What I can probably get down the line is going to be exam prep material, similar to Practice Lab, but straight from CompTIA. So I'm working on that as a partner for CompTIA, but you know, we just got funding like not too long ago. They just sent me the form 2 weeks ago. So in Python in this class, you can also test for Microsoft Python programming for beginners. So after this, you'll be able to certify through Certiport for that. And you can do it remotely. I gotta activate the license for individual ones, and then I will just, when you're ready, just send me an email after this class or during this class, and then I can give you the resource so you can certify for Python. In other classes like C++, Java, I am also releasing that too. So,
Okay,
but
great.
so I will let you know as soon as I get the license in my hand, and I'm hoping by the end of this month I should be able to secure that. But sometimes administration process can be long, like it has to go to board. So my goal is to get it to board by the 14th, if they can give me the quote. So once I get the quote, fill out the form, it's gonna make board. If we don't make board, then we have to wait for the next month, and they only meet once a month, which is it's frustrating. But anyway, so I'll let you know as soon as I hear, so many things. All right. Okay, so let's talk about what we need to do today. Today, we're going to work on sets in Python, which is one of the container, the type, and like very similar to lists and dictionaries. So you're going to see some similarity and some methods that for sets. And then we're going to talk about functions. We're going to circle back and talk about switch comparison to other language like C++. Because earlier I remember a few of you asked me about how do you write switch case in Python. So I put an example program, and we're going to take a look at that program. Okay. So if you can access Canvas, download Unit 7 notes and also your assignment, and then we will discuss. Also, I want to share with you, I got your quizzes result. So Alberto got first place, and then Alma got second place. Elias got third place. Cynthia got fourth place. Andrea got fifth place. So there are quite a few of you who did really well on the quizzes or the quiz review game. And so your accuracy, as it is an easy quiz, right, is higher than most of my normal trend for quizzes. So I'm happy to see that. So I will send out e-gift to Alberto this time, and then we will do another one next week for the next quiz, okay? So notes, you can find it in Canvas here, and then the in-class assignment is right below. I will add the lab and then share that with you before the next session. Okay, so in the notes, and even when you read the chapter, there's some example program, but in chapter 12, it starts talking about sets, okay? And similarly, you see this in C++ when we use set STL. So this is a way that we can incorporate a container of unordered unique items. So every value inside this container has to be unique. It cannot be repeated. So in the case where you have 1, 2, 3, 4, 5, and if you're trying to add a number, let's say a number 3, that's already exists in a mutable set, it won't allow you to do that. So if you have taken CIS7, you've seen something like this on the mathematics side and also in the C++ side. I usually go over a little bit of the sets as far as the operations, but we can take a look at two sets and how we can have a union of the two sets, right? Like A and set B, and we can combine all the elements in those sets. Or we can have an intersection, which is an overlapping area. So for example, I have set A that would be 1, 2, 3, 4, 5. And then set B, I can have 3, 4, 5, 6, 7, 8, 9, 10. So the common values between these two sets will be the intersection, the overlapping of the sets. Okay. And then the complement just mean that would be the opposite of one set compared to the other. And then we can also take a look at the difference, right? So if I have 1, 2, 3, 4, 5, and then the other one is 3, 4, 5, 6, 7. So you have one set that has different elements than the other set. So we can take a look at the differences, whether it's symmetric or it's just generally a difference. So there are two types of sets. There would be the mutable sets. That means that we can iterate through the container and we can add or change or modify, right? The container itself. Or the immutable set, which is known as the frozen set, and you have to use the frozen set method to really say that this set is static. It doesn't change. We can only view the content of the set, maybe count up the value of that set, but we cannot modify the content inside that frozen set. So I didn't include all the example for all the methods, but many of the methods tie back to what you've seen for the mutable sets in a list and the other container. So here is an example. We have a tuple of vowels, and you know it's a tuple when it's using parentheses here. So vowels, we have I-E or A-E-I-O-U, and we would declare an F set is going to be a frozen set of vowels. And as you know, tuple is static as well, right? You would have initialized value for the tuple and it doesn't change. So what we can do is we can convert that tuple and make it into a set, a frozen set, right, where the element stays the same, and notice that they are unique. Okay, so, and they don't have to be in order. So the set could contain data, right, like values, and it, if you're using a frozen set, that's just a container that would have that value, that those values don't change. So now you can also have a frozen empty set. All that is that it just create that space, and it doesn't necessarily hold any value, but any set can contain an empty set by mathematical rule. So what we would see is that we can have an empty set, which is a space, and with that we don't have any value initialized. You cannot append to that frozen set because that frozen set is static. It doesn't change. Then you would have a frozen set that already contained a value. So we would use tuple container, right, values to show that in the set. So when you have the output, it's simply just show that you have a frozen set, and in the frozen set you would have these vowels. Now the set, it would use the curly brace, and if it's a frozen set you have to state that, and that would encapsulate, right, the container as a frozen set. So now the empty set, simply it to show that this is an empty set. So when you're using set, right, you would see that we would use the curly brace similar to dictionary, but we can have it mutable or immutable. Okay, so here's some information about creating a set. and the difference between a regular set and a frozen set. So you can use set to tell it it's a set, right? Or you can simply place the curly brace and assign the values for the elements in the set. So like many of the containers, we can determine the number of elements in the set by using length. Okay, so that will give us the length of that set. We can create a copy of the set. So I was playing with this a little bit last night to kind of see if I can do something with the copy. So what the copy will do is it creates another location in the memory, and it ties the address of that location to the original set. Now you cannot, in a mutable set, you cannot modify the copy, the shadow copy of it. You can only modify the original set, because all that is with the shadow copy is an address reference to the original set that was initialized. Okay, now we can also use the difference to return the items that is in one set and not in the other, right? Like if I have 1, 2, 3, 4, 5, 3, 4, 5, 6, right? I can look at what is contained in the first set that's different than the second set. That will be 1, 2, right? Because 3, 4, 5, 6 is in the other one. So we would look at the A minus B as part of the universe here. That would show you the difference, or vice versa. Okay? And then the intersection is going to be the items that exist in both sets, the common values or the elements that's in common for both sets. And then when you have two sets are completely disjointed, so if I have 1, 2, 3, 4, 5, and I have 10, 11, 12, 13, 14, 15, they're completely separated, we can check to see if those two sets are disjointed by using is disjointed. Okay. Now, if you have a set, you can also have a subset. So for example, I can have 1, 2, 3, 4, 5, 6, set A, and set B, I can have 3, 4, 5, 6, which is part of set A, right? Like, remember how we talk about a list within a list, right? So this is a container within a container. So we can see if set B is a subset of set A, right? So that would return true if the content of S is a set T. Okay. And then we can also look at the outer container if it's a superset. So if I have a larger set A and then set B is inside set A, I can check to see if set A is a superset. Okay. Now, symmetric difference is slightly different than just your regular difference. So we can return the items from either set, right, that is different from, so what it's going to look at both of the set and it's going to evaluate what items is not in the other. Okay. So it would look at the differences in both sets and give you those items. Where the difference, we can only look at the difference in one set or the other. Okay. And then I will run the program so you can see this. And then the union, we can look at the marriage of both sets, A and B. And it will return, right, in a larger sense, the combined items from set S or set T. Okay. So now here's the example. Let me open up my file so you can see how it's ran. So first we're going to take a look at the frozen set. Okay, so here's the program for the frozen set. So we have frozen set and we initialize 1, 2, 3, 4 for A, and then for B we have 3, 4, 5, 6, and then for C we have 5 and 6. So when we look at this, we can tell that C is a subset of B, right, based on the values, okay? And then that means that 5 and 6 also exist in B, okay? And we also see that there are intersections, common values between A and B, okay? So when we compare A to C, they have completely different values, so they are disjointed. Okay, so this should return true when you check for set A with set C. Now we can see if C is a subset of B, we know that these values exist in B, so we know that that would return true here. And then since B has a larger container, it contains more values, and so therefore that will be a superset of C. Okay, and then on this line right here, what we're doing is we are creating a copy of A. Okay, we are creating a copy of A as C, so we can print that out. So that all that does is it sets up the address and it references that address to the original values. And then for the union, we can have A union B. So that's going to give us the A values and the B values. 1, 2, 3, 4, 5, 6. Okay. Like I said earlier, the intersection is where we overlap from one set with the other. So the overlapping values are the common values in both sets. So 3 and 4 should show up. Okay. And then next, we would look at the difference between A and B. So when you're looking at A has 1, 2, and B doesn't, right? And B has 5, 6, and A doesn't. So it's going to list the difference, the difference from 1. When you tell it from 1, that's the difference. And then for the symmetric, it's going to list differences in both sets. Okay, so when we run this, we would see that we got true, true, true for the first 3. And then we created the copy, so it shows you the content of that copy. Then we look at the union of both sets, so it shows, it combines all those elements and created the container for that. Then we simply just do a print on that. It doesn't really change the container size or anything like that. Then we print out the intersection, which is the common values. We print out the difference from set A to B, and then we print out the symmetric difference with both sets. Okay. So you would see these type of operations more for mathematical analysis or data analysis in that level. So we don't, so you can use this to analyze your data, to compare, right, values across the container. Okay, so this is the example for the frozen set. Any question? No question. Okay, so you can see the code there. Now, when we go into the mutable set, that means that we can change the content for that set. We can add specific item to the set. We can clear, very much like list, right? When you clear, you simply just empty out the value. It's still gonna have the space, the memory space. So it's gonna remove the items as values, but it's still gonna have that space so you can update it. We can take a look at the difference and we can update it. So it's gonna remove the items from set S, and that is also in set T based on, so when you do this, it's gonna take a look at the difference and it's gonna update. So therefore it needs to remove the items, right, that is different. And it's gonna put that in T, okay? We can also discard items. So it removes specific item from the set. We can get rid of it, okay? Now with the intersections update, it removes the item from S that do not appear in the intersection for set S and T. Okay. Now when you add, you're gonna notice that it's gonna drop it in the front, okay? Because it's, last in first out deal. When it pops, it's gonna pop from the back. When it's add, it's gonna add to the front because those are gonna be last to pop. Okay, so when you pop, you simply returns and remove, right? You can pop a certain value, or if you leave it default empty, that's just gonna pop the last. Okay, we can also remove specific item. So there are a lot of similarity with the other containers. The true differences is that we can use some method for intersection and different sorts of symmetric difference. And when you need to add more than one item, you would do an update like list. Okay? So what we will do is I will open up the other one so you can see. Okay. So here we have a set of vowels. We start with an A and an E. Then we can print that out. We can say this is, the content of the set. Then we can simply do a vowels.add. And we specify here that we're going to add an O to it. Then we're going to print it. Now in this line, we're going to try to add A again. And remember that the set only contains unique items. So if the A already exists, it won't add it. It still process it. The program still continue to run, but there's no double A in the set. It will just be one A. Okay. Then we declare tup as a tuple, and we assign I and U inside that tuple. Then we can add that tuple. So when it prints, it's going to show that subset coming from a tuple with the parenthesis. So we did an add tup there. And then here's a different one. So you would have numbers 1, 2, 3, 4, 5 as a set. We create a new copy of a copy of the numbers, and then we would add the 5 to it. Okay, and then we would print both. Okay. Then lastly, we have two other sets. A is A, B, C, D. B is C, F, G. And then we can compare it. So first we find the difference A minus B. Those are going to be the elements. So it's going to show up with A, B, D. And then again, we would print out B minus A, the difference between B and A. So it should print out FG. Okay, so here we go. So you have the sets. These are mutable. Okay, we print out our set. We added the O, we added the A. It stays the same because the A is already there. We added the tuple, so it shows up as a subset there as a tuple. Okay, and then we have numbers. We print out the numbers. We have it copy. We added the 5. We print that out, and then we look at the difference between A and B, and then B and A. Okay, so that's the output for the mutable sets. Okay, so let's take a look at your assignment.
Professor, for the
Yes.
assignment, or actually for the notes, you guys need to delete is disjointed. It's just is disjoint.
Oh yeah, I'm sorry. I might have mistyped that. It is disjoint.
Yeah, I was figuring that out right now too.
Okay, so let's look at your assignments. Okay, so you have 3 sets, and they are frozen sets that's given 100, 200, 300 for A, and then your set B is 300, 400, 500, and your set C is 500, 600, 700. Okay, so I put this because, you know, grammatically that's correct, but when you put it into your, you use is disjoint as one word, right? So first we want to look at the intersection of A set and B set. We want to print that out. We want to look at the difference, right? So the intersection for A, that would be, I'm going to put a comment here, 300, right? We know that that's 300, A and B, because they have 300 in common. Okay. Then we look at the difference between A and B, and the difference that would be 100 and 200. Okay. And then we want to look at, to check to see if A is disjoint from C. Yes, they have completely different values, so that should be true. By looking at the numbers, I should be able to predict this, right? And we want to display the union of A and B. So that would be 100, 200, 300, 400, 500. And it won't show 300 twice because it has to be unique, right? And we want to do the symmetric difference. So it's going to look at the differences in both sets between B and C. So we know that coming from B, that would have 400 and 500. That's, I'm sorry, 400, that's different than C. And then for the C has 600 and 700 that B doesn't have. Okay, so that would be the symmetric difference. It's looking at both sets and it's identifying the different values. Where difference, it's only going to go whatever you specify. If you want to look at A to B, then that's A minus B. Okay, so as you're working on that, I will open this up. Okay, so at the top, I simply declare my set as a frozen set, and I put in the values, initialize those values as given. Okay. Then I first determine if the intersection of A set with B set. Then I print out the difference between A and B. I can then look at the disjoint between A and C. So I use is disjoint. And then I print out the union with A and B. And then I would use symmetric difference to display. So there we go. Now, since its order doesn't matter in the set, right, it's gonna pull the data as it evaluates on what you specified in your parameter and also how you applied it to the method. Any question? So exercise 1 is about using the immutable set, which is the frozen set. And we can compare the set by using different methods, or we can verify, right, on whether a set is different or not, disjointed or not. Any question? So this is also a type, yes, question?
Well, so you can't, the elements are not mutable. So that's why you can't access it with an index.
Right.
But you can iterate over it.
Yes. You cannot slice it because it's frozen. It's immutable. So we cannot slice it like how we would treat a list or other containers. Now with the way that we use set is that, yeah, you can print, you can basically you can see it, you can read it, but you cannot, in this case, you know, it's frozen, you cannot write over it.
Is there a difference in the memory allocation as a result?
Yes. So in the frozen set, there's no changes in the size in that. And so what it does is it just have that one address, and that's going to be the address that's, so when you can't pop it, right? You can't really get rid of it. So it creates, and it would use that reference. So even in an empty set, it creates that. And that would be the way that they have it created is for that specific type. whereas the list, you do see the changes, or the dictionary, you do see the changes in the size. And you know that there's a limit with stack, and also limit with how the program files would be. So when it's flowing, you know, in those type, it can actually flow, and on the physical location, it can, you know, go to other clusters. If you're looking at the drive or in RAM, it would buffer that out to other location. So yeah, offset is different. So basically you have like an allocated number of offsets for frozen set, where the offset for mutable containers are higher in range. So addresses is higher. And you can also, in Python, you can actually, you know, when you do a copy, you can actually show it, and it will tell you what address that is too. Okay. Because in the copy, sometimes you can, you know, in the shell, you can actually show that. And, you know, we'll talk about ID. I know that we touch a little bit on the membership operator, but I haven't gone over the ID operator yet. So we'll come back to the ID operator. We'll touch on that. Okay, question? So I think using the built-in methods like this, you know, it helps streamline a lot of the manual operation that we have to do when you compare this to like a C++ program or other languages, right? They do have set STL, and within set STL, you can have various member functions that could be used very close to this, right? But if for Python, the way they have it is that if you use frozen set, it would be like this. Yeah, you cannot slice it, you cannot. Okay, but you can look, you can print, you can view it, you can read it. Okay, questions with one? Okay, so let's take a look at the next one. Okay. So you have two sets that's given, letters 1 and letters 2. So we have D, E, F, G, and then letters 2 have H, I. Okay. So first we are going to do a shadow copy. Okay, so we want to copy letters 1 to letters 3 and then display. Okay. And then we want to add content to letters 2 of content of letters 2. So we want to add HI to letters 1 and display. And then we are going to look at the difference between 1 and 2. And then we're going to remove I. And then we're going to count the number of items in letters 1. And then we're going to use discard to eliminate the E and I from letters 1 set, and then print the content. Okay, so this gives you a little bit more practice with some of the methods that are listed there in the notes.
Is letter A supposed to be letters 2 set? Because there's no letters 3 set.
So you have to create an empty set for that first, or when you declare, you see.
Oh, okay.
So yeah. So it's implied that we would have another container that was not given, right?
Yeah.
Okay. So what we would have is, oh, I'm sorry, this is the wrong one.
Yeah, I applied for one for A. I copied letters 1 into letters 2. So that's, I thought there was no letters 3. That's the way I read it. Like, if maybe it was a mistake, but I guess it wasn't.
So for part A, so we want to copy content of letters 1 to letters 3. Okay, so what you can do is you can just create another container. So here, what I have is I first declare and assign the values for those sets. Then when I do a copy, I simply just declare that letters 3 is a copy of letters 1. Okay. Now, I'm going to run this real quick so you can see. So I can put it at the top so you guys can see better. Okay. So here, what we have is when we create a copy and then we simply just wanted to see what was in letters 1. So we print out the letters 1. Okay. And then you can do individual add. Add only takes 1 parameter. So you cannot add H comma I. It's not going to take. You can only do 1 at a time. Now, if you want to do add of multiple, then you want to have an update. And I commented that out, but I will add it so you can see. Okay. So you can also pull elements from the other container and update it. Okay. And that way and as we did it again, it doesn't matter because we already added the 2 originally. So when you update it, it doesn't change anything. It's the same value, so it stays the same after the add. Okay. So this is why we have the H. Oh yeah, the I and the H here. It stays there. Okay. And notice that it added to the beginning of this set because that was last in. That was last in. Okay. So now you would then determine the difference between 1 and 2. So it listed all the differences, right? So where here you have E, D, G, and F. They are disjointed, okay? Originally they are disjointed, but when you added the H and the I, they are intersected at H and I. Okay, then we're gonna remove the I and print it. So once we remove the I, it got rid of the I here, and we have H, E, G, D, F. We still have the H there because that was the last one that was added. Okay, then we do a count of our elements at that point. So it should give us 5, and you can see that that is 5. Okay. Then we're gonna go ahead and do a discard of E, get rid of the E. So we got rid of the E, so now it becomes H, G, D, F. And then we are going to discard the I, right? Which was already been gone. So it's done already. So there's nothing else to remove. Okay. And then we print it. Now I want to show you something. So when we do a copy there, let's say that I want to print letters 3, right? Because this is our container. So let me close it and reopen it. So okay, so you notice that when I did a print letters 3, it tells me that this is a copy of the set object and it is at this location. Okay, so because first it printed the content of 1, right? And I tell it to print the content of 3, which is the shadow copy of the 1. It simply just state that, oh, there's it's referencing that object at this location after we did a copy. Okay, so you don't necessarily get the same content as 1. All it's telling you is that it's gonna say this is the address for that object that was a copy of 1. Okay, question? Any question? We're okay?
Wait, just to
Yes.
repeat, for the adding the H and the I, you said you had to do that because why?
When you use add method, it only takes 1 parameter, 1
Wait.
item in parameter.
Could you use the update without using
Yes.
the add?
Yes.
Oh, okay.
So you can do one or the other. I originally had this comment out, so it's the same.
Oh, okay.
Yeah. So when you have 2 or more items to include or add to the set, you want to use update. Okay.
Okay.
If you do add individually, you have to do 1 at a time.
Would you use the update function if, say, you were adding a list that the user inputted?
Yeah, you can do that, but then so you have to first have an empty list that the user would store the user input, and then you can use that list to update the set.
Because otherwise you wouldn't know what to add, right?
Right. You can have it, if you're using list and list, you can have it append, right? Each as it loops through. Or if you can take that whole container and then you can do an update to a set. Yeah, you can do that.
Okay.
Good.
Thank you.
You're welcome. Yeah, we'll come back to that. We're going to talk about case switch with the user input, down the line. So, with functions. Okay, any question with number 2? Okay, so play with this a little bit. You can experiment with other methods as well. I only designed the assignments to address the majority. It's not going to hit every single method because that would take us hours just to, so I'm not keen on torturing you guys that way. But if you want to hone your skill, you can, just write additional script. That will be good. Okay, so for 3, before we get into 3, let's talk about another container. So I should close that note. Okay, so here in the notes, it gives you some example that we went over, using copies, using different methods. So one of the things that the author of the book added was the collection module. And in the COR, the course outline of record for this class, we incorporated that we required that you would implement some form of module. So Python has this module called collections, and it's a different way that we can use data types for high performance reasons. When you take data structure courses like 17C and C++ or 18C for Java, you would often see that you would, use a different type, or you would create or write a program that construct, right, a different type of container where you can access, in some cases, one end of the container to add or remove, values, items, or in other cases, like we would use the DEX, right, to be able to add and remove on both sides. So that way it would be fast, right? We want fast, we want something constructive that we can operate quickly. So with the name tuple, that will create a tuple subclass with a given field. So a lot of these type of container, it actually is an advanced or higher level of your basic container. So you do see DEX using the same type of operation as some of the other containers, okay? So DEX allows us to have a list that we can use both ends to either append or pop. So earlier you saw that using a set, when you add it, it puts it in the front, and then when you pop it, you get rid of it at the end. Or you can point to the value and it's going to seek that value and it's going to pop it or remove it, okay? So with DEX, what we can do is we can do it both sides. We can do it at the left or we can do it at the right, okay? So either end. So that's what's cool about it. And here it gives you additional details about the collections. So a chain map, it is a class very much like the dictionary. It gives you a view showing where it counts up the hashing objects and it maps to it. And then the ordered dictionary, this is a subclass of dictionary, and it would use a way we can do the order of the entries. So it would organize it and it will remember it as the order, okay? Default dictionary, that's gonna allow you to call a function that supply the missing value. And with the user dict, user list, and user string, these are rarely used, but these are types that would be wrappers for the base class, okay? So what I want is I want you to experiment with dec, which is the double-ended queue. And you can write a single-ended queue. You can do a single-ended list, right? So based on a container concept, what we can do is we can create a container, and what we can do is we can access it both sides, which gives us a double-ended queue or the deck, okay? So the objects are similar to lists, and it supports appends and pop, and it uses threaded safe memory efficient. So this is more of a recommended container if you want high performance and you deal with large data set. So it is mutable, right? You can change the content within it. It is faster, so you can insert on both sides and you can remove on both sides. Okay, so now what we can see is we can look at the example. Notice that you need to import collections at the top. Okay, and here what we have is we would declare a deck called double-ended, and with that we would have Monday, Tuesday, Wednesday. and we will print it. Okay. Then what we can do is we can append Thursday to the right. So after Wednesday, we wanted to add Thursday there. So if you just use append, it automatically puts it into the right side. Okay. Now, what if you wanted to put Sunday to the left of Monday, right? To keep it organized, then you use append left method. Then you can put Sunday before Monday. Okay. Now, if you want to remove from the right side, you simply just pop it and it would go to the right and it would get rid of that. And if you want to remove from the left, you simply pop left. Okay. And then you can also use the reverse where you switch everything, reverse everything from left to right, right to left. Okay. So let's take a look at the deck. And for Python, it's simpler compared to other languages, right? So here's the deck program. Okay. So I use the same example here. When I run this, you can see. So first we have Monday, Tuesday, Wednesday. Then we would add Thursday to the right. Then we append Sunday to the left. So we append Thursday right, Sunday left. Then we pop Thursday. That was the last thing that comes in on the right side. We pop that. And then if we want to remove Sunday, we do a pop left. So it goes the first one on the left and it got rid of it. And then when we reverse, when you do a reverse, it puts Wednesday before Tuesday and Tuesday before Monday. Okay. Any question on deck? So deck is for double-ended queue. Okay. So let's look at exercise 3. So you have months._DQ. So months DQ, and it is a deck. So we have March, April, and May. We want to append June, July, and August to the right side of the deck. So you simply just do append there. Okay. Speaking of Certiport, they just responded to my email. Okay. And then we want to append left for December, January, and Feb. Okay. Then we're going to remove the first item. So we're going to do a pop left. And then we're going to remove the last item so that we're just going to do a pop. And then we can remove June from the deck by specifying June. Okay. And I think that's it, right? Yep. Okay. So let's take a look at the program while you're working on that. Okay, so I simply put import collections at the top. Okay, make sure you do that. And then we declare our deck. This is the identifier, that's the name of it. And we're saying that we're using the collections module and it is a deck. And then here is our assigned elements, March, April, and May. Then I'm going to do append June, July, and August. And then I print it. Then we're going to append left December, January, and February and print it. Then we're gonna get rid of the last. So we're gonna do a pop. And we're gonna get rid of the first. We're gonna do a pop left. So it should get rid of August and December by that point. And then I'm gonna remove June. So here we go. Okay. Question. Now in C++, if you're familiar with it, you have to do the node and then you have to use pointer to point to which node is first and which node is last, so that way you can add and you can insert and remove from first or last. That's how you would do a double-ended queue for on the C++ side, but Python is much simpler. So you can use a module and then be able to do that. Question?
You can use extend, right, for the first one?
Yeah.
Oh.
I just do a pen, so you follow. A pen is that way you can see each one being added, so you know that, you know, this is just a practice, so that way you know that it would put it in, you know, in that list. But
Okay.
you can use it for many different things. Double-ended queue. When I taught C17C, I made them do it for the fact that they have to do like a search algorithm, you know, different type of search algorithm using the DEX. So it can access on both sides. But, you know, you can implement it for binary search. You can do, so containers can be used, and every programmer has a choice in that, right? So this is an option for you, basically.
Dr. Nguyen,
Yes, Cynthia.
is this the best way to approach the this code or this program, or is there another way to?
So, what do you mean approach? As in specific method, or? So I would start with declaring your deck, but you have, when you're using your deck, you have to use the collection module. Okay.
Oh, okay. Mm-hmm.
Yeah, and then so we have to use what they gave us, which is the 3 months to start. Okay. Now, if you choose to do a pen, we can do one at a time, right? Or if you put those into another list, and then you can do it that way too. But I just do a pen because it's easy. Now that would add these guys to the right of May. So it's gonna do June, July, and August. Okay, but the double-ended queue, you can use both sides of it, right? The containers, just think about it like at home. Let's say that if you need to climb up the ladder, right? Usually on the ladder we can only access the bottom up so we can go onto the roof. So you have to climb from the lowest step to the next step to the next step, right?
Mm-hmm.
But think of this as a way that we can actually access the ladder on both sides. Like we can climb it on that end or this end, right?
Mm-hmm.
So in a container, what we can do is we can make it where we can access data on the left or on the right, instead of just the traditional way is only the right-hand side.
Oh, okay.
Yeah. So with this one, when you do an append left, what you're doing is you adding it to the left and you adding it to the right. Right?
Oh, okay, I see. Uh-huh.
Uh-huh.
Okay, that makes sense.
So yeah. So this and it makes it faster because it's still allowing you to still use the container, but instead of doing one by one on the right hand side and adding everything. So that what happened if I wanted to access January or March, right, at the beginning?
Mhm.
Well, if traditionally, if it's a one direction, we have to get rid of all the other ones before we can get to January, right? But on the double-ended deck, if you access it from both sides, it's quicker, right? You can go directly to it, and then December, January, boom, we're done, instead of going all through the other months. So it's more efficient. Yeah, definitely. So the way you see this, you should look at it as a linear, like a line, right?
Mhm.
If we need to access the earlier values, we can do it from this end, or we can do it from this end.
Okay. Thank you.
Okay? You're welcome. So yes, you have to start it with declaring the deck like how they stated it in the questions, and then you can decide on, you know, how you would append that. Okay.
So you can convert any container into a deck and vice versa?
If they're mutable. Just like in C++ or Java, if you have an array, you can make that array and convert it into a single-ended or a double-ended. Basically, you just state which node and how you access the node. So the way that Python has it, they already built in the node for you as part of the module. So it tells you that, you know, the beginning node and the ending node, right? That's your element, your items. So that way, and in C++ and Java, you got to point to those. So you have to use a pointer. We don't in this case. Okay. Because it will just go to that address and it will just access those items or the location to add or remove those. Okay, question. So this is exercise 3 using deck. And you can achieve, right, the same objective in Python compared to other languages, right? If you look at this program in C++, it would be longer, or Java, that will be longer. Okay. But here we're not using class, or we're not using anything. We use a built-in class from the module, and we use the built-in methods with this. So, okay. Question. All right, let's see. Are you guys ready for the next one?
Dr. Wen, I have one more question.
Sure.
With this program, what do we so how would we apply this program to the like real life situation?
So in real life situations, so let's say that you have a business and you have prices for all your products, right?
Mm-hmm.
And let's say that I have 100 products and I add each price into this list, okay? Different prices for my product. Then I got a surplus shipment of more products, okay?
Mm-hmm.
And now the prices also change. Let's say that the vendor increased the price and I have to update my old prices. So what I can do is if I created a deck, right, to store all my prices, what I can do is I can remove the old prices on both sides, right, and then update it. It will be quicker than going through it sequentially. Like
Yeah.
if you're looking at the traditional list, and I have to go and like delete, right, and then, you know, update a subgroup or modify those values. with this is I can say, oh, well, the beginning of the list, we want to raise it by $5. So let's do that. Let's write a function and then access the beginning and change that, right? And then the end of our deck, we want to make maybe like double the price. Then we can double the price at the end, right? So that will be quicker instead of just, you know, running a for loop that accessing every sequential element and then be able to do that, because you might have unique subgroup that would require different things like raise by $5, double the price, or even discount the price, right? So yeah, definitely quicker.
Oh, I see. Okay, thank you.
You're welcome. Other questions? Okay, so let's talk about functions.
Yeah.
Finally. So I'm gonna ease you into it. So it's really easy, right? Okay, so that was Dex. So functions is cool, right? It's a way that we can break our program into sub pieces. So for example, right, like let's say that you want to write a program to print out all the network devices at your work, okay? And then you're gonna take those names and then you're gonna update it, right? Like let's say that we add certain value to those names. So that's 2 tasks. So first we want to make an inventory list of all the network devices. Then what we're gonna do is we're gonna modify those names by adding, like let's say, more letters, okay? More letters, more characters to it. Then we're gonna print it out again. So what you can do in that is you can create 3 separate functions for that one particular program to make it into more, to solve the sub problem, and then to be able to consolidate all of them, put them all in one program and be able to run it, right? Versus writing 3 separate programs. So what we can do is we can use all of that. Now, yeah, the beginner students, they're gonna write one whole entire program, right? And then complete each task. It's still gonna be able to achieve that, but what happens is when you have separate functions, you can troubleshoot your program in pieces, right? Like or modify your program in pieces. So treat it like a more of a modular approach, in a way that we can organically change, you know, that function itself to do something over time. And that's why functions are very useful in programming. So what it's saying here is that we can utilize it to break our code into subpart, and then be able to use those subtasks to solve the bigger problems in pieces. And it helps with troubleshooting, because we don't have to troubleshoot the entire thing. We can actually troubleshoot the area that's needed, the function that has problems. Okay, so, and you should always approach programming that way. It doesn't matter what language, right? If we can make it into the subtasks, we can use those subtasks to build the bigger program. So we would have the related statements that perform specific tasks. Like I said, we can print out the network list, the network devices list. We can update it and then using a different function, and then we can reprint the updated. Okay, so the function help us break it into the smaller modular chunks, which is great. So there are 2 types of functions. You've been using a lot of the built-in, right? There's some built-in functions, and then there's some that we can create. We can create them. The programmer has a choice, right? If it's not already there as a built-in, we can make a function. We can define it, and then we can make it do something. So user-created functions. So those are the 2 types. okay? And when you start writing a function in programming, what we first have to say is, first, we got to define what that function is, right? So in C++, what we normally do is we would have some kind of statement saying that this is the function that I'm using and this is what it is, okay? So in Python, we simply would say def, def, to just define it. And then we give it a name. So you would use the same way that you would name any identifier in Python or programming. You have to start with a letter, right? And then you would want it to be unique and it would be represented to what you're doing in that function. So if I'm doing, you know, network device list, I would say show network device, right? Something like that. Or, you know, ID network device, whatever, right? So we would want to create a unique identifier for that function, a name for it. After you specify that, you have to complete it with a colon, right? That marks the end of the function header. So like in C++, you would say int, right? Like display, whatever, value. And then you do a semicolon, right? So here what we have is we would need to have a colon to finish out that header, the function header, and then we would have a body of that function to say this is what it's going to be doing. We would print, right, this, or we would sum this, we would multiply this, whatever you're trying to do there. So with Python, what we want is we want to use a def, right? And then we would add the function name next to it. And then the parameters, what you're using could be a variable, right? It could be a list, it could be a container, right? It could be values, right? You can also use a comma to separate, right, different parameters that you would have, okay? And then here, that will be your statements. That's part of the function, but remember you need to indent, okay? Indentation is important in Python because if you don't, it's gonna throw an error. It's gonna say, oh, that's not the right syntax. So we want to indent. Okay, question? So here, right, I have name and I would have the user input his or her or their name. And then I would do, here is where I would have the function header. I would have def, greet. Greet is the name of my function. And I would use the parameter name, right? So the whole purpose of this function is to say hello and plug in the name and good day, okay? So in the function body, we want to, the statement is that we want to print hello and then plug in the username that they input and say good day. And down here is when we do the function call. So in C++, you would have this tie into the main, right? Well, all you have to do for Python is go down a little further, right, in your text editor. After your function header, right, and the definition of your function, what you want is you want to call the function there. So you simply take its name and its parameter and then put it here, okay? Now, if you want to return something, you need to put that, right, with the statement return, etc. But, so this is one way, one program using the function, creating a function. Another one is following. You have absolute value, that's the name of your function, and you know it's a function to use def here. And then we would have num. Okay? So it says that if it's greater n equal to 0, return num, else return negative num. Then we would call this, right? So this is used inside the print method, and then we want to check for 2, so it should print 2, and then it should print 4 because we want to convert that to the absolute value. Okay, so now
So you have an option of whether to use the return function or print, but you would not use you wouldn't return a print statement, right?
no, yeah. So you just return, or you can print. You can use the inside print method. So here is my function program, right? So this one we looked at right now, right? And then this one is to do the absolute value, okay? And then another one, we would do a total sum. And, you know, I call it the running sum, right? With the for loop. So we would calculate sum of 5, 4, 3, 2, 1, add them all together. That should give you 15, okay? And then here's another function to display hi or hello. Okay, so let me run this. Okay. So enter my name. So I'm going to put my name, and it says, hello, Casey, good day, right? That was the first program. We would have greet function there. And then my absolute value, right? It converts that to 2 and 4 for me. And then the running sum for this program, we use 5, 4, 3, 2, 1. That's the parameter. So we would have 15. And then on the last one, I simply call display argument. It's going to show the first one is hello, the second one is 4, and the third one is hi. So that kind of give you a little bit of some example on how you can write a function. Okay. Any question?
Dr. Wynn?
Yes.
I had a question. So just to make sure I'm on the right track, when you return something, you're always returning your function, right?
Yeah, so this one, they return the value from the parameter.
Oh,
Yeah, so you return, so the function, if you have it calculate something, right, you want that value to be returned, right? You want it to, because you wanted to know what that value is. So, and in some cases, if you might see when we use like condition statement, you can say, if this is true, return 1. If it's false, return 0, right? So you can also have it that way. So it would show, so you can type in to check the value, and if it's 1, then you know it's true. So you can do it that way too. But yeah, so you can have a container where it would store your value, and then you just bring that value forward by doing a return statement.
Okay, thank you.
Okay, you're welcome. Question.
So for functions, at least so far, we have to define it before we can call it?
Yes.
Okay.
Right. And in C++, it's the same way. You have the function header at the top, and then you would have the definition somewhere on the bottom, and then the main is where you call it. There are 3 parts in C++. This one, you just have the definition and then the call.
Okay.
Yeah, and the way you tell it that it's a definition of a function is using def, give it a name, and then whatever parameter, colon, and then the body is your statement on what it's task is to do.
So is there any way, like in C++, you have all the functions at the bottom? Is there any way to like
Yeah.
move them in Python so I don't so it makes
Yeah,
the
so
body
you can
look not as
organize it.
big?
You
Yeah.
you can organize it. Yeah, you can have it called, but you want to call for the purpose of your program now. You don't want it to just to put it at the bottom because it looks better. You wanted to call it for the purpose of your program. So I would call, because remember the interpreter, it goes line by line. Whereas
right.
the other one, it compile everything and it looks at different parts and it's gonna say, oh, okay. So you have to keep in mind that it is sequential, line by line. So at a certain section of your code, this is where you would call. And it's like that for some other, like when I teach assembly, it's like that for assembly, because the emulator, when it gets to that line, it needs something, right? If you want that call there, you need to place it there. Because if you place it at the bottom, it will be out of place.
Okay.
Okay.
Thank you.
You're welcome. Other question?
So Dr. Wen, when you call the function, like for example, am I calling absolute value? Like
Yes. Yes.
Okay.
So think of it this way, Cynthia. Let's say that you, in your family, there's a baby that's born. You define that baby name first. Okay? Yeah, so you say, let's say that baby's name is Lisa. You can say Def Lisa, colon, right? And then this is about Lisa. Lisa is a cute baby. She talks when she's 2, etc., right? So that's how the function is. You first give it a name and say what it's doing, right?
Right.
And then when you need Lisa to do something, you call on her. Just say Lisa, right? So the same way, you name it, absolute value, and then when you want it to show the output, yeah, just call the name. So when we say function calls, you just add that name there. You don't, because you already define it. So the interpreter would know. So you call it here. Yeah. So absolute value is called here, and we use a 2 with it, right? Any parameter, because num could be 1, could be 5, could be 5,000. Okay.
Okay. Thank you.
You're welcome. Other questions? Okay, so let's do the next one. No question?
Yeah, I had a quick question. I don't know if you said it earlier, but what's the asterisk for that's inside the parameters next to the word argument?
Oh, for here?
Yeah.
Yeah, so that is just to reference. So it could be anything. So using this argument, it's a keyword that's passed. So you can use a keyword that's being passed. Argument as the keyword.
So if you want to put multiple keywords instead of writing each individual keyword,
right? Yes,
that's a shortcut.
Right. So yeah, so that's kind of like it's sort of like the wild, right? So you can say, oh, instead of a group of things, you say, oh, I'm just gonna use this, and it's gonna point to that. So it's kind of like a way that we can reference. But yeah, so instead of having argument 1, 2, and 3 like this, right, you can use the asterisk. Okay, question. Good question.
What's the difference between the 1 asterisk and the 2 asterisks? Because you have 1 for the calculate total sum, and then you have 2 for the display argument function.
Can I answer that?
Yes, Chris.
So the multiple asterisks is that's when you actually want to define a keyword, right? When you want to define the keyword, like for example, on the function call that she has, she's putting argument 1 equals hello. So when it only has 1 asterisk, there's no definition. You can put as many keywords as you want and whatever you call them. But once you have a double asterisk, that means that there's going to be
You
one that
have
is
to define.
defined it exactly.
Yeah, so in this case, like I have 5 here for the arguments, right? And I didn't really say what they are to start with, right? I didn't say that, you know, number is 5, 4, 3, 2, 1, right? I just say that, oh, whatever the parameters is, just plug them in, okay, for arguments. Now for here, when you're using double right here, what you have to do is you have to specify what they are, okay? So
Okay.
if you want specific, then you would do a double, where you would, if you just wanted to say, okay, yeah, those are the keywords, right? Then we would just use a single. Good job, Chris.
Thank you.
Mhm.
Thanks.
All right, so let's look at the next one. Use a function in Python program to determine if the user age is under 65. Okay, so, and that's just one line, really easy. So you might have already worked on this. So yes, you can make it where it's not a function, right? But we want to learn how to define a function, call it. Okay, so I have user age. This is my global variable right here because I wanted possibly to use it for other things. So if you want it to be local, then it's only to that function that's accessing it. Where if you want it global, then you put it at the top so other function could use it. And then I would define, I use check age, okay, as a function name. And then I pass the user age. And then I simply use an if else statement inside that function and said if user age is less than 65, print you are under 65. Else print your age is 65 or higher. So, and then I call it. Okay. And sorry, let me exit because it's getting to the end. Okay. I should have clicked close and then instead of exit, sorry. Okay, so this is our program, and then when we run it, let's say that we put 45 and it says you're under 65, right? And then we can run it again. And let's say we put 70, and then that should check. Very easy. Question. So we call it here, right, by name, and then use the parameter. And don't forget when you have input, if you're doing like, you know, integers, we gotta make sure we parse it for integer. Otherwise, it's gonna throw an error if you don't put the int. Any question with number 4? This one is very simple, easy. Okay, so again, we're gonna do a function for number 5, right? You given nums 1, 3, 5, 7, and we want to double each of the value and display the result, okay? So to approach this, we first got to declare this at the top, right? Make it global so that way it's accessible for that function in case we also need to add other functions. So then I would need to also be able to access each of the value in the index. So you have to use like a for loop. And then we will multiply each value by 2. Okay, so first accessing it with index, and then we multiply it by 2. Okay, so okay, so here I have nums 1, 3, 5, 7, and then I name my function double nums, right? And then I pass nums. Now I wanted to set up a container so that way I would store the value. So I would have a list there, an empty list to start, and then I have a for loop for I in range length num. So I want to iterate through each index to access each of the index value. And then as I access the index, I would multiply it, each of the value by 2, and then put it into my list. Okay, and then I print it. Okay, and after I have the task for my function, under the definition here, I would call it double nums nums. So there you go. I have 2, 6, 10, 14. So when we double odd number, we get even.
Question.
Yes.
So is it the same like in C++, the name in the parameter doesn't have to match the name of the global variable? Like, do you have to write nums, or could it just be something else
You can,
inside
yeah,
the...
you can use the value directly in it. You can use like, you know, you can use double num at the end when you call it here. You can do 1, 3, 5, 7, and it will do it.
But I mean, in the definition of the function, do we have to write nums in the parentheses, or could it be another name?
Well, whatever you name, whatever you use for that container. If you have a variable, if you have an identifier that stores something, the whole point in parameters to be able to plug in that value inside the parameter.
Okay.
Right.
Thank
So I
you.
would plug in one. Yeah. Okay.
Yeah, I got it. I got it. It makes sense.
Okay. Okay.
Thank you.
Question? So if you wanted to make it more fancy, then you can take everything, append it to a list, and then print it to a list, right? You know, but I did have an empty list, and it did store it there, and it did print each of the value as it loops through. So each time it loops. you know. So yeah, it all depends on what you really wanted out of this. We just wanted to print the results, so. Any question? This is number 5, is when we double each of the value in the list. We created a function, we defined it, and then we use a for loop to access the index. Then we double each value as we access it and print. And then lastly, we call the function.
A question.
Yes.
So just to confirm, that nums could be a list, tuple, set, or a deck?
Yeah, container that you would store some form of value, right? You can put directly, you can put, yeah, so you can put directly values into the parameter, but if you're using nums, you just, basically it's a container. Okay. And I can have more, right? I can have in here, I can have this and other, it's parameters, so you don't have to have only one. So if you wanted, if you have another list, let's say nums1 or nums A, and then you have a bunch of other numbers, you can also do the same thing. You can double all of those too, right? By calling for both lists. So if I tweak this, right, if you, right, so let's say I have nums1 equal, let's say 6, 7, 6, 8, 10, like this. I forgot the, right? And then here, what we can do is we can have it now, because it's 2 separate lists, right? We can make another for loop for this, access it, print it, but when you call it here, you can do a nums1 like that, okay? So you can have more than one parameter. Question? Okay, you guys ready for the last one?
Yes.
Okay, last one before 4, I know. So this one is a dictionary. You're giving prod, and I'm sorry, I was probably really tired at this point. I apologize. I type everything twice. So your product, tomato, you basically, it's produce and color, right? So I have tomato red, squash yellow, potato brown, avocado green. We're going to create a function to display each key and its value, like tomato and red. And then we want to use globals and locals method to display the container detail. So if it's global, right, it will tell you that what variable or what container is global. And then if certain container is a local variable or local list or whatever, it will tell you. And it also tells you whether you have built-in function or customized function. So let me get my program open. So you can see. Okay. So first we simply just declare our dictionary like what they gave us in the question. So prod, right, all of these. And then I use the show prod for my function name, and I simply pass the prod there. And I put for ij in prod.items, because remember last week we talked about using the items to show the values of the key. Then we want to print ij. Okay, and then we call the function. So show prod, right? And then here I just simply do a print locals and print globals. So when we run this, you can see that as it loops through, it's gonna show me, this is kind of like what we did last time. Tomato red, squash yellow, potato brown, and avocado green. And that was my function to get those printed. And then I have print locals and globals. So it tells me that I have built-in function that's local and then built-in function that's global. Okay, so what do they mean by that? Items is built in, format is built in. And then I also have built-in locals. Oh yeah, so there's to the function itself, there's some built-in, and then to the global itself, there's some built-in. So it checked for me and it tells me that. So if you wanted to see if you have built-in local functions or built-in locals variable to your functions or global variables in your function, you can check that way. Okay. So this is number 6. Define your definition. So here's my header. And then I have the for loop because you have to access the key and the value. So we wanted to do ij. And then we want to use the .items method. And then we want to print. Question? So our output is this, right? We have tomato red, squash yellow, potato brown, avocado green.
Are we gonna do lambda functions at some point?
Yeah, maybe next time, or I'm going to talk a little bit about that now since we have a little bit of the minutes. You can actually implement lambda as, into what we call switch case for C++. But I did added a screenshot for you guys to see what that switch case would look like in Python at the end. And it ties to what we talk about today, which is function. So, all right. Any questions with 6?
Oh, Dr. Wen, I had just one little question.
Sure.
I was wondering, it's not a good idea to name your function the same name as your dictionary, right, or list?
No, yeah. So you don't want to have the same identifier. It's gonna confuse you and it's gonna confuse the system.
Okay.
So yeah, so I would modify the name a little bit, and when you take programming classes, a lot of the time, the book or the instructor, they will tell you to really use the name. Like there's, they would use like show to like display, right? Get is when you're trying to obtain. So if I wanted to like, have the user input age, I would say get age, right? And show age. So yeah, so you would use some, that would be a standard way to kind of name your function, because in programming, we only either input or output, and that's what we do. So you can use like show or get or, or calculate.
Okay, thank you.
You're welcome. Other questions? Okay, So real quick, just a few more minutes. So here it talks a little bit about the globals and the locals with the variables, and then also use it, you know, to check for the variables. At the end, I added the switch in Python. So the first part in black, this is a switch case that would be written in C, or you can do C++. So in C++ and Java, you would do a case, and then you would do a break, right? And then you would do as many cases as you want. So in this one, we're gonna do one for each day from Monday through Sunday, okay? And simply we ask the user to select the number, and that number would represent the day. Okay, so for Python, this is what it would look like. So there's no switch case for Python as part of the control statement. It just, you're gonna have to write the function for it. So you would do a def Monday, return Monday, def Tuesday, return Tuesday, Wednesday, and so forth. So one for each one, and then your default would be an incorrect day, right? Like if I put in a number 8, it's gonna tell me, nope, that's not one of the days. And then we just have a container called switcher, and then we would use a dictionary to say that the key, if the key is 1, that would be Monday. So if the user press 1, it's gonna say Monday, okay? If the key is 2, it's Tuesday, and so forth. So you simply assign, right, the key and its value accordingly for each day of the week. Then after that, you have another function called def switch. And here is where we would use day of the week as parameter. And you can use a .get, right, to obtain. So we would return switcher, which is from here, right, and then get day of the week and then the default. So what that is, we might have to pass the default, and that default allows us to control input or input validation. And then you would print switch user choice, because user choice is basically declared at the top as an input. Okay, I have this program created, so let me show you real quick before we end. So here it is, right? When we run this, it asks me, enter 1 for Monday, 2 for Tuesday, and 7 for Sunday. So let's say if I put 6, so it tells me Saturday, right? So in a way, this is not exactly like our switch case statement and with the break, right? We have to implement functions for different subtasks to kind of break it up and be able to pull everything together at the end to check for the option of the user. So if you want to do like menus or options for your customers, this will be something like this, okay? Just 2 parallel switch case. Any question? Okay. So if you complete your assignments for today, you can upload it. If you miss anything from the prior weeks, make sure you get those to me. I think I'm trying to keep up with your grading for this class, but yeah, so we'll come back and do lab exercises on Wednesday. Hope you have a good late afternoon and evening, and I'll see you on Wednesday. Okay.
See you Wednesday. Or
All right,
later
bye.
on.
Have a good day.
Thank you.
Oh, sorry. Thank you, Dr. Nguyen.
Oh, you're welcome. Have a good night. Bye.
Bye.
Sean, you okay? You have any question? Have a good night, Sean. Bye.